Section 8.2, using properties of parallelograms. Little reminder, a parallelogram is an equilateral with both pairs of opposite sides parallel. And let's go right into the theorems. Theorem 8.3. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So, if PQRS is a parallelogram, then PQ is equal to RS. It actually should be congruent. Let me fix that. Is congruent. So PQ is congruent to RS, and PS is congruent to QR. So the opposite sides are congruent. Theorem 8.4. If a quadrilateral is a parallelogram, then its opposite angles are congruent. So I have PQRS again. If it's a parallelogram, then angle P and angle R are congruent, and angle Q and angle S are congruent. First example. Find the values of x and y. ABCD is a parallelogram by definition of a parallelogram. Use theorem 8.3 to find the value of x. So if theorem 8.3 says if it's a parallelogram, then the opposite sides are congruent. These two are congruent, and then these two angles are congruent. So we're just going to set them equal to each other. Solve for x. Subtract 4. And then y is easy. Not too hard. Okay, you try to. Find FG and the measure of angle G for number 1. And for number 2, find the values of x and y. Push pause and do the work in your notes. Okay, check out the answers. Next section, interior angles. The consecutive mean one after another. Consecutive interior angles theorem states that if two parallel lines are cut by a transversal, then the pairs of consecutive interior angles formed are supplementary. They add to 180 degrees. A pair of consecutive angles in a parallelogram are like a pair of consecutive interior angles between parallel lines. If you look at this parallelogram, I have two parallel lines right there and a transversal. So x plus y equals 180. Okay, two parallel lines and a transversal. These are consecutive. So if you add them together, you get 180. As shown, part of the extending arm of a desk lamp is a parallelogram. The angles of the parallelogram change as the lamp is raised and lowered. Find the measure of angle BCD when ADC is 110. Those are consecutive, okay? So they have to add to 180. So angle BCD is 70 degrees. Theorem 8.6. If a quadrilateral is a parallelogram, then its diagonals bisect each other. So I've drawn parallelogram PQRS. And then I drew in the diagonals. So if you look, diagonals, they bisect each other. Bisect means cut into equal pieces. So these two parallelograms bisect each other, which means this segment and this segment are congruent, and this segment and this segment are congruent, which are stated right there. Okay, you guys all just moan because you saw a graph, and yes, that means that we're doing the distance formula. The diagonals of LMNO intersect at point P. What are the coordinates of P? So the diagonals of a parallelogram bisect each other. So P is the midpoint of the diagonals LN and OM. So, sorry, not distance formula. We're doing the midpoint formula. So, midpoint, we do add the x's and divide by 2, add the y's, and divide by 2. So if I look at ln, the midpoint of ln, I have 1, 1, 1, 2, 3, 4. That's point L. And point N is 1, 2, 3, 4, 5, 6.
Why, fabulous.
Okay, so I have the points. Let me go ahead and do the midpoint now. 1 plus 6 over 2, and 4 plus 0 over 2. That gives me 1 plus 6 is 7 over 2, 4 plus 0 is 2, or 4 over 2, which is 2. Okay, that would be where it is, where the midpoint is, so it's where the two lines are bisected. Okay, find the indicated measure in parallelogram JKLM. So I'm going to push pause. Okay, use what you've learned to answer the questions. There you go. Bring your questions tomorrow if anything confused you. Daily homework quiz, page 1 and page 2. Okay? 2 points extra credit. Turn it into the inbox in the morning.